So I'm telling you the logic to organize the elements of the array in an ascending order. How we have to sort them. So I have to reorganize the data and put it in an ascending order, smaller to higher values. So for that, I'm just telling one logic. Just observe that. I'm just comparing this one with this. Organizing it, smaller one should be the left and larger one should be the right. Now we just compare. Is the first value larger than the second value? Is it greater than the second value? Is the first value more than the second value?
Yes, ma'am.
Yes, ma'am.
So I need to rearrange them. Means in that array it should come in this position. This is called swapping. No? Is this called swapping?
Yes, ma'am.
You know the logic of swapping two values? I want to swap which values now? So
Array of
anybody?
0 with array of 1.
No. So anybody can tell me this logic to swap. Means as of now it is 12 and 5, but later it should come as like this. So what is the logics you have learned to swap two elements?
Um,
Using a third variable.
Yes. Third variable, copy this first here. So coding wise, how do we write that? I have to copy 12 into the temporary variable. Means what is the first thing we have to do to swap? Say 12 in the temporary variable. What is the coding for that? If you have a t as a temporary variable, your temp as a temporary variable, what should we find? First step, I should copy the first value into the temporary variable. If this is the AR, this is the array. What happened? Nobody is understanding. It's a simple concept. No? Copy 12 into 10.
Temp is equal to array of 0.
Yes. Okay. Then second step, copy this into this location.
Array of 0 is equal to array of 1.
Last, whatever was there in 10, we have to copy in this
Array
location.
of temp.
And we have another way. Actually, there are 4 to 5 ways. I taught only 2. Without third variable, with third variable. But if you are a basic interview point of view, if you have to check, we have to learn all the 4-5 steps of it. 4-5 ways to swap the elements. Understood that? So now what I want to say is, we compare the two elements because they are not in an order, ascending order. I have swapped the elements and now the array elements will look somewhat like this. Is it right? After swapping. Yeah, perfect.
You didn't teach me this method, ma'am. You said so. You said without taking another variable, 12 plus 5.
Didn't I
addition
teach?
with addition.
Yes, yes. Didn't I teach this third variable one? I teach this
With
only first
first
actually.
addition.
Then I teach. Okay. What is that with the addition without third variable? Swap without third variable. What is the logic
Array
for
of
that?
array of 0 equal to array of 1 plus array of 0 plus array of 1.
Okay. So now in array of 0 we have 70. Okay then.
Array of 1 equal to array of 0 minus array of 1.
So with this, array of 1 becomes
Um, 7.
7 or 5.
5.
Then
Now array of 0 equal to array of 1 minus array of no, array of 0, array of 1 minus array of 0.
array of 1. Array of 1 is how much?
5.
Array of 0 is 17. Array of 1 is 5.
Array of 0
No,
minus
array of 0 minus array of 1.
The same thing. Whatever I've written up, same thing we have to subtract, but here it's first AR of 1, second time it's AR of 0. So it will become 2. Whatever step you do, it's okay. Without a third, with the third. Better is this one. Because we are saving 2 bytes of memory. Now, this is clear. That means I'm just telling you the steps right now. So initially, I compared the first one with the second one. If first one is greater than the second, we are swapping them. So it became like this. Now, compare these two. Is it greater than the second one?
After changing, ma'am.
Yeah, after changing, we got this one. Previously it was 12.5, no? Now it is 5.12. And now we are comparing the index 1 value with index 2 value.
Greater.
So it's greater, not true. So what should we do? Swap these two. So it will come in this one. Array will look like this. Coding is same, but variables will change. Instead of AR of 0, 1, it will come with AR of 1 and 2. Swapping will happen between AR of 1 and 2. Okay. After that, we'll move on to this comparison. I'm moving in a systematic order. First, we compare these two. Next, we compare these two. We are moving to the right side. Okay. Now, is it swapping or not swapping?
not swap.
So, no swap. No swap. So, it will remain as it is. Now, after that, that means we got the same. No changes in the array. Now, we are moving to the next. Is it swapping?
Yes, ma'am.
So, that means this will get swapped and we'll get. Okay. By this, now how does the array look like? Did any number reach to its correct position?
No.
Is any of the 5 numbers
Last
present in the correct position?
52.
That means which index is sorted right now?
AR of 4.
4 is sorted. Now I
Fourth
don't have to
index.
touch it. Now again repeat the same procedure of comparison starting from here till last second. Is it more? Okay. Swapping takes place. Then I'm comparing these two. Is it more? Is it going to swap?
No.
Is it false? So when it is false, no swapping takes place. It looks like this. Now we have to compare this. Is it more than that?
Yes.
So we have to
Yes.
swap. So it comes like this and the procedure stops here. By this, which element got sorted right now? Come to the correct position. Already 52 reached the correct position. Now second largest value is in the correct position. Now same procedure we are going to repeat. False, no changes. Compare again with. Is it more?
Yes.
So we'll swap them. So by this, last 3 digits have got placed in the correct position. Again repeat the same procedure between the two and we found it's larger. This is sorted. Now the first one has reached to the correct position. Now can you tell me the pattern of comparison? If you look at that pattern, which elements we compare? Initially which one we compared?
AR of
Which
0 and AR of
AR of 0 with
AR of
after that.
AR of 1 with AR of 2.
Okay. Now instead of writing these AR, I'm just writing the indexes. First we compare the 0th element with 1. After that,
1 with
1
2.
2 with 3.
right? By this gets sorted. Element in the 4th index will be correct. Now come down. Second traversal. This is one traversal. We moved once from left to right and we got the last element sorted. Come down. Second traversal. Again we started from which comparison?
0 with 1.
By which this is sorted. Once we moved from here to here, this got sorted. Come down. Again we start back again from the beginning. By this is sorted. Come down and compare the two. This gets sorted and it's already one left. That is already in the correct position. So this is the same pattern now. We have learned because for
Yes.
comparison it's not linear, it is two-dimensional pattern now. So definitely more traversals. If it is only searching between smallest number, it is only one traversal. That is linear. I am not moving once on the array from left to right. I am moving again and again from left to right. So initially we traversed on the array from 0th index till last. That is one traversal. After that, second traversal. That means we are traversing on the array for how many times? 4 times. Every time we are just comparing two numbers here and it's getting reduced. So we know the pattern now. How to write this pattern, you have an idea. Now only thing what we have to write here, array comparison. So already we know that patterns. J starts at 0, j is than or equal to I, j plus plus. Based on that, I starts at
3.
till yeah,
Oh,
3.
4.
3 or 4? Think. This is j,
3 only.
this is j plus. Because we have two values, no? So j last value is this one. This is j plus 1.
1.
So
3.
3.
I greater than or equal to 0.
okay. So here what are we trying to do? We are comparing. Which element with which element you are comparing? Array, which
0.
element with which element? In that array, which element
J.
AR
J
of
and J.
shape is compared with?
J plus 1.
Okay, when should I swap them? At which condition? What is the condition to swap them?
Array of J greater than array of J plus 1.
So write the logic of swap here. I'm not writing the logic, you know the logic right now. Swap logic between J with J plus 1 element. Okay? Pair of J with pair of J plus 1. We have to swap them. Is this clear? Any confusion? After
No,
you
ma'am.
finish this, you can print the array. Let me just execute and show you this logic. Now, all of you remember the logic now? This part. Now, this is the logic of sorting an array elements, and this logic is called as bubble sort. This way of sorting the elements is called as bubble sorting. There are many ways to sort an array. This is just one way, one of the sorting techniques. I'm just taking all the values in reverse order. The complete array is in a reverse order. And for sorting, we need how many variables here?
2.
2 for traversals. What should we do? What is the logic of traversal for these comparisons?
Ma'am.
What is the loop logic here? loops, pattern of the loops. Comparison pattern is which
For,
order?
for j equal to 0, j
Yes.
less than or equal to I, j plus plus
I do.
I, I equal to 3,
Greater than or equal to.
greater than or equal to 0, I minus minus.
What are we comparing?
Array of j greater than array of j plus 1,
It should be right here for swapping.
array of j equal to 10,
Alright. Yeah. If you have to take a third. Otherwise, you can use that formula. Arithmetic formula. Is equal to
array of
Array
j
of
plus 1,
j plus 1.
temp equal to array of j plus 1.
whatever is there in temporary, it should go into
Array of j plus 1 equal to temp.
Okay.
just see in this manner. Like this is in a flow. A is equal to B, B is equal to C, like that. Just flow in that order. Temp is AR of J. Again, AR of J will come here. AR of J is equal to AR of J plus 1. Same thing will come here. Will be taken with permission. Okay. Now,
Yes, ma'am.
I'll just show you before sort and after sort. Just to print it, I'm just writing the loop. So logic is clear to all of you. Anybody has confusion in the logic? Why we have learned the pattern? Why we have done that? Okay, these are written inside the loop. Let me write it out. Inside the loop. Is it sorted?
Yes, ma'am.
Yes.
And you write any
Yes, ma'am.
order, it will jump over. It will get the lines. Here, this is called as bubble sort. Why it's given as bubble is like jumping. Bubble means like, see when you see the bubble they come out, no? Bubble means it should come out by nature. So here the last element will come out. We will sort and put the correct number in the last place. Then we'll come to the last second. So it will come down, right? Or else you can simply like from here it will jump to this, from here it will jump to this. Like we're moving to right side direction. Actually bubble means it should come out. So topmost will come out, then the next will come out, then the next will come out. So we are sorting in that order, last to first. Is this clear? Now if I have to sort them in descending order, what should I do? Changes in this. I want to sort the same elements in descending order. What should we do?
In if condition, you have to check.
Is it okay? Clear? Any confusion?
Ma'am,
Yeah, got it.
is there any other easy way, ma'am? Because we are
Okay. You have
plenty
to,
for this.
yeah, I'll do. You have to tell me if there is an easy way. I'll ask you, you have to tell me. I'll just give one best example here. Now, 5 students are standing in height wise. Okay, whatever. They are just standing there height wise. You have to make them stand in height wise as a new. What should we do? If people are standing in the row like this, you want them to stand in height wise, increasing order. What will you do if you have to arrange people in a height wise, shortest to height, tallest? What procedure you apply?
We'll
Do you use this concept in real time to arrange them in an order? Do you use this technique, what we have done just now? When people are standing in a line, you have to make them height wise. So what will you do? Which logic you'll apply?
directly will take the the higher number.
Directly you take what you want to take. Ascending order. I
Highest
want
number.
to ascending order.
Smallest number.
So that means take the smallest number. Smallest number means we have to find, no? Can I say this? Is it the same thing? Take the smallest number means we are looking for a smallest number, no?
Yes, ma'am.
After that, what you should do? I search throughout the array and I found 4 is the smallest number. What should we do? Without disturbing everyone, what will you do? Generally, in real time, what we do is this person will come in the picture. Generally, no? What we do is we do generally like this. Rest all people will stand. That means they'll move to the next. In real time, if we have to arrange them in height wise, this will be in this pattern. Is it right? Are you going to do this in real time? The person who is shortest, they will come to the front and everybody will move to the next, no? They'll move behind. Is it right? Imagine the
Yeah, ma'am.
scenario. If I do like this, everybody have to move backwards.
Yeah, ma'am.
That means everybody is moving, no? Everybody is changing their position, no? Because this person was in the first, he moves to the second. Second person moves to the third. So everybody is disturbed here. Is it right? Without disturbing all, can you put the shortest person in the correct position? Because here we disturbed everyone. Everybody had to change the position.
Interchanging only
Only the
uh,
4 in the
smallest with
yeah. So or
previous
simply
one.
simply can I say put the 4 in its correct position because you are searching for the first smallest number or the number which should be present at which location? Zeroth location.
Zero.
So I am searching for zeroth location. I found it. It's present in which location?
Second.
So what will I do now? I'll swap this with zeroth element. as of now. So then the element looks something like this. After that, what should we do again? Now you can leave this number 4. Now what should we do again?
5 with 13.
Yeah, we are searching for the second smallest number, or the number which should be at which index? Index
1.
number 1. So once we find where is the second smallest number, at which position it is found, number is important or position is important?
Position.
Position. So first find out where is the next smallest number present, since it is found at the index number 1. Now what should we do? We have to swap with which index? Sorry, index number 2. It should be swapped with index number 1. Right? Now just observe. By doing this way, we'll arrange all the people in an order. But did we swap them frequently, like previously how we did? In the previous pattern, whenever we found wrong order, we swapped them. Immediately we had to interchange. Even then, again, second time we had to swap. Again, they were not proper. So we had to do a lot of swappings there, unnecessarily. But here, once I moved from left to right for the first reversal, how many swaps we have done?
1 swap.
Only one swap. Means third reversal maximum one only. You can't exceed that. It may be 0 or 1. If already the smallest number is in the correct position, I don't even have to swap it. So for every traversal, we have to either do maximum swap as 1 or minimum 0 swaps. So if I have to swap also, maximum how many swaps will take place in this traversals? 4 traversals, 4 swaps will be. So is it saving some time in this execution? If I execute the program in this way, is it reducing the time of execution when compared to this one?
Yes, ma'am.
Because there are a lot of swaps, this logic has to execute. It will take some time for executing this swapping logic. And this swapping logic is happening so many times. But here it is not happening that many times. Okay, now how do we code for it? This sort is called as selection sort. You are selecting for a smallest number and placing it in its correct position. Swapping it with the correct position. Okay. Now, just think for a code how we have to do it. Now, there were some values given to it. You're given the values. What is the first thing you have to enter? First step in the selection sort. In first reversal.
Smallest number.
So you are finding which element, small mean value, to be placed in which position.
0th position.
So when I say this traversal, I'll call it as 0th traversal. Let me see. Okay, let me try it one only, but you have to count in mind. You are searching for the number to be placed in which position? 0th index. So you have to search for the smallest of all the 5 values. Or you want to search for the smallest element of all. So from there we will search for the smallest element. Assumption starts from the first number itself.
First number.
You know the logic, no? How to find the smallest of an array.
Yes, ma'am.
So write that logic. You found out the value. Do I need the value or do I need the index? Smallest value is this. Do I need to save this or do I need to know this one?
Position.
Yes. I have to find the mean values index. So we are searching for, that means we are searching for minimum value to be placed in zeroth index and find its position. That is important for us. So now it is found at index. After that, what should we do? Once we find out the, we have to traverse completely from here to here. Then
Swap with that index with first 0th index.
swap the value
Minimum
at min index with which value?
0th index.
By this, zeroth index is sorted. After that, I'll go for the second traversal. Again, second traversal means it has to start for the, since we're talking about the
First
index,
first.
index 1, for the index 1, you want to place the correct value at index 1. This procedure was for to place the correct value in which index? So now again we'll search of min of how many values?
4 values.
4 values. From which index to which index?
1 to 4.
1. Once we find that index, that means we found wherever the min is found. Now min is found in index number 3. Now what should we do after that?
Swapping.
Index
First.
so now just think for 2 minutes and tell me the code. What should we do in the code part? This sorting or we are searching will be done for how many indexes? This is done for which index initially?
First.
0.
Then we have to do for which index?
1.
We have to do for how many such indexes?
5.
0 to
Think it.
Oh, sorry, 4.
Think it.
Last one.
I want to see which number should be at this place so that I am looking at how many indexes? Remaining 4 indexes. Then I'll swap it if it's 1. Then I'll be searching which number should be placed here because there are 3 more values. Now after that I want to see which number should be placed here, so I'll compare with these values. Compare. I want to see which number should be placed here and compare with this value. Right now all the 4 values got sorted. Should I check for this again?
No.
No, by the time we place 4, it is already the correct value. Right? So this traversal should happen. How many traversals should take place?
4 times.
4 traversals.
4.
Starting from which index?
0.
0.
Starting from 0 till
3.
3. So, can I take the for loop for this traversal iteration? Okay. Okay. Now, I have written the traversals. Now, 0th traversal means the first traversal. What do we want to do when I am traversing? What exactly we want to do? I want to find out which number should be placed in this index. Which index? Which number should be placed in the 0th index? Now we want to search for 0th index. What is our logic to find min of an array?
Taking I of 0 as minimum and
Yes.
comparing.
So we said here, min as previously we did smallest number as.
Array of 0.
So now am I memorizing the values or the indexes?
Sorry, ma'am.
Am I memorizing the numbers or the indexes here in this concept in the selection
Index.
software? So should I save the number or should I save its location?
Location.
Location is important. My assumption
Yes.
here is I'm assuming that smallest number is found at which index?
0 within.
Okay, ith index. That means as of now 0. Now we have to search from which indexes now. I want to see which number should come at this point. So we have to look at whichever indexes.
1 to 4.
1 to 4. If this is the current index, I want to traverse from which index onwards?
1.
So if it is 0, it will traverse from 1. But if it is 1, second traversal starts from here to here. Huh? So for the second traversal, we should start comparing with.
I plus 1.
So we'll start comparing with remaining other values after that I. If I am searching for the ith element, then I will compare with all the remaining elements from next indexes. So I have to go for a traversal. If I have to find which number should be at this place, I have to compare this value with 1, 2. So this traversal should go on. Wherever whichever number is found, its index we have to see.
Both.
What are we checking here? What should I compare?
Smallest.
Yes, element at this index is compared with which index? As of now, I'm searching this only as a minimum. This is my smallest elements index. Smallest element is found at which index? This index. I'll compare with remaining other indexes. These are indexes. So I'm comparing the array element found at which index
With
with other elements. Other elements at which index?
A.
J.
When should I change my min index? Now min is 0. When should min be updated? I'm assuming min is present in the 0th index.
Array of
Array of
min
0.
greater than array of j.
Yes, that means if the other number, or let me write it as, if the other number is found to be greater or less.
Now less than or less than
The current
array of
minimum. Current element found at the minimum index. So what should I do if it is so? Smaller element as of now assume